All right, this video is over section 2.7, and 2.7 is the start of our real big word problem section. I'm going to go through a couple examples here. I have another video that's linked to the review for final exams. We'll make sure that you get a hold of that one as well, because really the hard part of this chapter is not so much doing each individual word problem. It's being able to pick out what kind of word problems each one is. Or each one, what type you're dealing with. So it's not that bad, here, but, as we go forward, it becomes a little more tricky as we go through the rest of the unit here. So let's just take a look and we'll see where we are and see what happens here. All right. A ratio is a comparison of two quantities by division. Equivalent ratios can be written as a proportion. Okay. So when we start looking at this is the two words I want to look at for vocab: ratio and proportion. And again, the rest of this you'll start figuring stuff out or looking at it in your classes. But we want to make sure, number one, that we can reduce fractions and do all of that stuff. So this should have been bell work. Make sure if you have this set of notes that you try that. If you don't, it might not be a bad idea to pause the video and just make sure it works. And if you have questions, ask your teacher about it. But let's get into actually doing some of the problems. And really what these videos are meant to do is help you with the concepts that you're learning on any given day. So let's take a look at what's happening here. All right. A cell phone company found that 15% of their phones sold in June were defective. The company sold 250 phones in June. All right. How many of the 300 phones sold in July should they expect to be defective? So if you notice, this is all about June, this first set right here. And then the stuff I'm underlining here in blue, this is all about July. Okay, so these are what we call proportion problems, proportion word problems, because you're basically presented with two different scenarios. You've got one scenario for June, and in this case, and then one scenario for July. So those are your two different types of scenarios. Now, the way you set this up, or the way you look at this, is keep each scenario as one fraction. So in other words, I'm going to say June, and I'm going to say July. All right, so they say in June, 15 out of their 250 phones were defective. So notice how I have this set up. This was the defective on top, and then this on the bottom was the total. All right, I have to set that up the exact same way for July. So they had 300 phones sold. We don't know how many are defective. All right, now we can put an equal sign between those, and we have a proportion here. So after we have it set up, this isn't too bad. We've talked about how to do this several times. All you would do is cross multiply this and solve. So I would take 15 times 300, and then 250 times x. Probably easier to do 50 times x first. All right, and then do the 15 times 300, and you get 4,500. Okay, and then the way you solve this, obviously, is just like we always do, get the x by itself. 250's got to go. It's attached, so divide each side by 250. All right, now you can go to your calculator to do that. So 4, 5, 0, 0 divided by 250. Okay, you get 18. So we would expect 18 phones to be defective. All right. So again, another way you can look at that is, again, just think about it. It's two separate scenarios. It's a really good indication that we're dealing with a proportion. Okay. Let's look at number one here. Number one's really, or number two. Number two is really the same type of thing. All right. The ratio of boys to girls in a given art class is 3 to 5. So this is one art class, right? 3 to 5. So this is boys. This is girls. If there are 12 boys in the art class, how many girls are there in the art class? So this is one scenario, the ratio that they give you, the 3 to 5. And then the other situation they give you is they throw the actual numbers in here. So remember, boys went on top. So 12 boys needs to go on top from this. And we want to know how many girls there are. So there's your setup. Again, you could cross multiply to solve it. Okay, just want to give you the setups here. Again, as this is a quick reference, just to help you get things set up for the word problems. The solving shouldn't be too difficult for you. All right, so along with proportions, the next type of problems we have are what we call unit rate problems. And the unit rate, if you think about it, is you always just want to figure out like per one unit. Okay, so it's actually really easy to do. Number one, an ostrich can run 174 feet in 3 seconds. Well, you know it can run 174 feet in 3 seconds. It's okay, it's useful, but what we'd probably be more interested in is how many feet can it run in 1 second. So unit rate, really all you're going to do is just take the two numbers and divide them. All right. These are word problems, so you can use your calculator for it, and you can use your calculator for any problem, but you can keep it as a decimal answer, and that's okay. So 374 divided by 3, okay, gives you 58. So 58 feet per second. Now the thing is just make sure you keep your units labeled. The feet were on top, so my answer, the feet go on top. Seconds was on bottom, so my answer, seconds goes on bottom. All right, real simple on those. So just be careful with that. Okay, and the next set of stuff we have here is going into conversions here. All right, let's skip to number 5. And there's a number of ways to do these. What I like to do is treat these kind of as separate problems. When I do that, I just want to be really careful about how I write it and go from there. So right now I have gallons, 120 gallons per 1 hour. All right, I need to convert this from gallons. I need gallons go to cups, and then I need to make hours here go to minutes. Okay, and the word per just means divide. So if I'm thinking about how to do this, I could get real fancy and creative with this, but I'm going to do it really easily here. So when I convert stuff, I always want to start with what they give me. So they give me 120 gallons. Okay, and I want to multiply that by what we call the conversion rate or the conversion factor. All right, well that's this. How many gallons are there in a cup, or how many feet are there in a yard if we're talking distance and stuff like that. Now the way I do this, I'm going to put times after that. All right, this is called dimensional analysis. I want to keep my units and my dimensions on here in the right order. So I want to go from gallons to cups. So from that 1 gallon to 16 cups, whatever I want to convert to goes on the top of the fraction. So I want to convert to cups. So 16 cups goes on top. 1 gallon goes on bottom. And the reason I'm going to do that is because the units drop out. See, when I cancel them out. So I have gallons on top with gallons on bottom. They're going to go away. And then here's what I have. So all I do now is I just multiply this together. So 120 times 16 over 1. Just treat it as a fraction there. Okay, so 120 times 16 over 1, which is just 16. That gives me 1920, 1920. Okay, so that was me converting the gallons to cups. Now I have this other part, all right, in blue that I have an arrow drawn to. I have to go hours to minutes. All right, well, this one's pretty easy, right? We already know. We don't really need to do any math here because we already know that 1 hour is equal to 60 minutes. Okay, so since we know that, we're okay here. This is pretty straightforward. It's pretty easy. So this 1920, I want to keep my units on here. This was cups. Well, the question says go to cups per minute, right? Instead of gallons per hour, or go to cups per minute. How many cups per minute? So I'm going to take the number of cups, all right, the 1,920 cups. I'm going to divide that by the minutes. Okay, and then just throw it in your calculator. Easy. 1,920 divided by 60. all right, equals 32. So this would be 32, keep your units, cups per minute or per 1 minute. And there we go. Okay, that's how you do a basic unit conversion. Just a quick review on proportions. How do we solve proportions? Let's look at number 2 and number 3 here. All right. Remember, we cross multiply. 5 times 8 is 40 equals x times 3, which is 3x. Okay, and then now you just solve it. So you just divide by 3. So you get x equals 40 over 3. All right, if I go the other route here, go this side. Now, when I take 4 times x plus 3, I have to multiply that 4 by everything, by the x and the 3. So that gives me 4x plus 12 equals, then take the 7 times the x equals 7x. So now we get into all the stuff we've been working on the last, chapter, where we've got variables on both sides. So this has got to go to the other side. Okay, and then we're just going to solve it. So you get x equals 4.